Hey, Algebra 2 students, today we are going to take a look at factoring x cubed expressions. And before today, any x cubed that we had, it was because there was a GCF. So this is totally new stuff, not too bad. So first thing we want to take a look at is we are going to focus on factoring two terms that are either being added or subtracted. This works if both the first term and the last term can be written as something cubed. If they can, then the pattern holds. A plus b times a squared minus a times b plus b squared for the sum, and for the difference, a minus b times a squared plus a times b plus b squared. This product, or sorry about this pattern, okay, is for the sum and difference of cubes, something you need to memorize. So we take a look at number one. First of all, how many terms? There are two terms that are being added. Well, take a look. The first term is x cubed. Can we rewrite 8 as x cubed? And the answer is yes. So I rewrite this as x cubed plus 2 cubed, because 2 times 2 is 4 and 2 times 2 again is 8. If I can do this, then I can use the pattern. X would be my A term, 2 would be my B term. So let's use that pattern. I would have x plus 2 times x squared minus A times B, so x times 2 is 2x, plus the B term squared, so 2 squared is 4. Again, this is the pattern that works when you have the sum of two cubes. When we look at number 2, I have two terms being subtracted. Okay, the first term is something cubed. Can I rewrite 27 as something cubed? And the answer is yes. X cubed minus 3 cubed. That's a squared. How about cubed? There we go. So if I can do this, then I can use the pattern. X would be my A term, 3 would be my B term. Factors using the pattern, x minus 3 times the A term squared, so x squared, plus A times B, so x times 3, which is 3x, plus B squared, which is 9. So your job before you come to class on Monday is to memorize, put this in your bank of tools for factoring. Sum and difference of cubed, know what the patterns are. Okay? Then let's know how to use them with these two basic examples. So again, this slide was for the sum and difference of two cubes. Two terms, both written as something cubed. Now let's take a look at the next slide. The biggest difference that should jump at you that this is 4 terms. The only way to factor 4 terms is to factor by grouping. So just like the name says, we are going to group these terms. First, check and see our polynomial is standard form. X cubed, squared, x to the first, constant. I group them. Group the first two together, group the second two together. Now, in those first two terms, do I have a greatest common factor? The answer is yes, it is x squared. If I take an x squared out of both of those terms, I'm left with x plus 3. Now let's look at the next set. Do I have a greatest common factor? The answer is yes. It is 16, so I take out a positive 16. I'm left with x plus 3. Now notice that both of these, we had 4 terms, now I have 2 terms. This one is a term, and this one is a term. And both of those terms share a common factor of x plus 3. If I take that common factor of x plus 3 out, I would be left with the x squared and plus 16. So I factored out of both of those terms the quantity x plus 3. Now this is as factored as I can get because I cannot factor the sum of two squares. Let's try it again. So my directions say factor. I notice I have 4 terms. Okay, the only way to factor 4 terms is to factor by grouping. So I take a look here and I group the first 2 and the second 2. Okay. Well, what do these two have in common? Okay. I can take out definitely an x squared. Okay. And what's a common factor between 27 and 45? Well, you're right. The answer is 9. So if I take out a 9x squared, I'm left with 3x plus 5. Okay, well, if you can tell from this first example, these two quantities have to be the same. So we take a look at here, well, what is a common factor between 3 and 5? The answer is nothing, except for, notice that they're both negative. I can factor out a negative 1. Leaves me with 3x plus 5. Aha! So a good mental check is, are these two quantities the same? If the answer is yes, you are on the right track. So I'm going to factor this whole quantity out. I take out the 3x plus 5, and I'm left with these two right here, a 9x squared minus 1. So I want to look and see, can I factor any further with either of these quantities? Well, 3x plus 5 doesn't factor. But notice that 9x squared minus 1 is the difference of two squares. The difference of two squares factors to a squared minus b squared. Factors to a plus b and a minus b. Okay, that's back from chapter 4. Well, what's the a term? So this would factor to 3x plus 1 and 3x minus 1. So we factored twice in this problem. We factored first by grouping. We looked and we said, well, what do we have left over? Okay. Can either one of those quantities be factored any further? The answer is yes. This is the difference of two squares. Okay. So that is factoring sum and difference of cubes and factoring by grouping. I would like you to try these video examples right here and be ready for Monday. On Monday, we're going to take it a little further. What happens when you have a GCF in there? What happens when you have leading coefficients? So here are the basics. Give them a try, and thanks so much for watching my video.